Welcome back from our short break. We still want to look into what exactly happens, at a particle level in as far as a physical change is concerned. Now, let's look at exactly what that means in terms of, the changes in size and shape. But remember, this has a lot to do with physical change in as far as, matter is concerned. Right. So what are some of the observations in terms of phase changes of any form of matter or material? Let's take our attention and, put it into the change when a material is a solid and then it changes into a liquid. These are the, aspects of a physical change that we need to actually look into. We can look at it in terms of the shape of the material. If a material changes from solid to liquid, does the shape change or does it remain the same? The texture of the material, does it change, as well as the color, as well as density? But remember, density has a lot to do with the ratio of mass to unit volume of a substance. Okay, now this has a lot to do with the packaging of particles, in a given state of matter. So if a solid changes to a liquid, does the density of the very same material change? So these are the observations that we want to zoom our focus into, right? Okay, now what about also the change in mass? Mass has a lot to do with the amount of matter making up a substance. So if a substance changes from solid to liquid, does the mass actually change or not? So there is no change in mass, while physical or chemical properties of that substance also do not change. So if we go back to the previous slide, we know that if a solid changes to a liquid, there will be a change in shape, in texture, in color. There may be a change in color as well as the density, because density has a lot to do with these two properties or quantities, which is mass and volume of a substance, which is also influenced by the packaging, right? But what does not change is, in as far as that is concerned, is actually the mass, the amount of matter that makes up a substance. When it changes from solid to liquid, actually does not change, as well as the physical and chemical properties. So it means it's still the same substance, but in a different phase altogether. Right, now let's look at exactly what happens using a simulation when a substance changes or a material changes from solid to liquid. So if we go to our simulation, okay, we have got it's a substance here we can use. In this case, we've got neon. Okay, it is in solid form. Okay, what exactly do we realize in terms of the arrangement of particles? There is some definiteness in terms of the shape, in terms of the size. But then for it to change, for this substance to change phase from, solid to liquid, what we need to heat that. So the moment we apply some heat, you can tell already the particles are starting to move further apart, and the extent of movement actually becomes comparatively higher. So we want to check about shape. The shape is definitely has changed. What about the spaces, which will affect the density or the amount of space it covers? It will definitely change. So these are some of the illustrations at a particle level of exactly what happens when a substance changes from solid to liquid. So in its solid state, this is what we initially had. Right. Okay. Now, having said that, so we understand exactly what happens to particles making up a solid when it changes to liquid. Right. Now, and then from liquid to gas, there's a change in shape, there's a change in texture, there's a change in color. There may be a change in color. There also may be a change in density. Okay, this appeals a lot to the arrangement of particles. How particles are packed. In terms of spaces and the forces that exist between particles that make up that substance. Okay, so that's very important. But when a substance changes from liquid to gas, there is no change in either mass or the physical property or chemical properties. So what do we mean by no change in physical? If we start with a substance, water for argument's sake, and heat it from liquid to gas, So when that process or that transition or change happens, it's still the same substance. Is the chemical composition is still the same. It still has got the same physical properties. So actually, in a phase change for any substance, for that matter, we can therefore generalize that there is no change in mass as well as physical and chemical properties. Right. Okay. Now we can illustrate that again by way of a simulation, right? We'll start, let's take water for argument's sake, it's in liquid form. Now we want to change it into a gas. What happens? We're gonna heat this. One thing for sure, there is no definiteness in terms of shape, of the substance, but the amount of space that the liquid occupies is something that can be, determined. But then if we heat this substance, what happens to it? The spaces between the particles increases, and the volume, it will also affect the density, okay? But the mass is still the same because the amount of matter making up this substance is still the same, right? So this is what we actually pick up from that simulation, as a way of, trying to understand what happens at a particular level. So in terms of phase changes, if a substance melts, it changes from solid to liquid. Chemical composition, mass remains the same. The process involved is melting. The change is from solid to liquid, right? What else? We also have seen that we can also change a substance from liquid to gas. The process involved is boiling or evaporation. This is actually accompanied by heating, okay? But what has happened, chemical composition and the amount of matter, which appeals to the mass of the substance, actually remains the same. And then we've got another change that we did not demonstrate using the simulation, whereby a substance can change from a solid to a gas, or vice versa, from a gas to a solid, without going through a liquid phase. In the very same process of sublimation, mass of substance, chemical composition remains constant, or it does not change, right? Then the reverse, from gas to liquid, will be our condensation process. Okay, so they are different. And then from liquid to solid, it's freezing. Now, if we go the blue route, actually it has to do with cooling, while the red arrows show that we have to add energy or heat the substance for us to realize that type of a change, right? So in representing phases of matter from solid to liquid, we know that when ice melts to form water, we would refer to water because it commonly exists as a liquid at room temperature, right? So when we represent phase change, it's very important to indicate the state. So we've got solid, we've got liquid, we've got gaseous substance, or a combination of the two. But it's very important to also indicate the phase, right? Okay. Now we can also talk about representing a change from a liquid to a gas. But what is important in this physical change here is that the chemical composition of the substance on the left is the same as that on the right. It's still the same substance. However, what has changed is the phase. Then this could be accompanied by changes, in shape of, or in volume, which also affects the density of the material. So this is how we exactly represent a change from a liquid to a gas. So this is actually a physical type of a change, right? So if we are to, for argument's sake, represent any change, what remains the same, in all cases, as long as it is a physical change, is that the substance on the left of that change, I'm not going to use the word reaction because it refers to something else that we'll look at, at a later stage of this lesson. We would say then the substance on the left actually is the same in terms of chemical composition to the substance that is on the right. Okay, so that's a physical change. But what's so important about the demonstrations that we've done up to thus far is that we need to realize that as long as a physical change, mass, which is actually the amount of matter making up that substance, as long as a physical type of a change, which is, for argument's sake, from a solid, heating a solid and it becoming a liquid, the mass does not change. It remains constant. because the amount of matter is still the same. While at the same time, if we're saying the substance on the left and on the right is actually of the same type of chemical composition, then it means even the physical property will remain constant. Why? Because it's still the same substance. But what could change in any physical change is, we can talk of the shape, okay? We know a solid, you've got some have got regular, but there's a definiteness of the shape, we can also talk about, the size, in terms of the space that it occupies. And the word size, we would want to relate it to the volume in terms of matter occupying, space or taking volume. So if the volume does change, it would impact on the density. Why? Because density actually has to do with the ratio of mass to volume of a substance. Okay, so that's as far as the types of change is concerned and how exactly we represent it. Now that's as far as the different types of changes of matter. For now, we'll take a short break and take our discussion further after the short break. See you shortly.